Yesterday we started solving quadratic equations. How did we solve them yesterday? Graphing. And what did we look for when we were trying to solve equations by graphing? We looked for the x-intercept. We looked where it crossed the x-axis, right? Okay. And so how did we write the answers? Sometimes we wrote it x equals, but sometimes we wrote it as a point, right? As an x-intercept. Okay. So really it's going to depend on what the directions ask for to how you're going to write the answer. So just pay attention to that, please. Okay. Today we're going to solve quadratics by factoring. Okay. Most of you in this room are fairly decent at factoring, so we're not going to focus on the factoring so much. We will just a little bit, just as a reminder, but we're mostly going to focus on solving the equation. Okay, we're just going to be using factoring. So if we're looking at problem number A in this sample, what do you think we should do first? Well, if we read the directions at the top, you would notice that we should follow these steps to solve quadratic equations by factoring. Number 1, set each equation equal to 0. So how do we set this equation equal to 0? So if I subtract the 6 from each side, I get x squared minus x minus 6 equals 0. Correct? Okay. Step number 2, factor. How do we factor a trinomial with a leading coefficient of 1? Multiplies to be negative 6, adds to be negative 1. Good. What two numbers multiply to be negative 6 and add to be negative 1? What kind of 2 and 3? Negative 3 and positive 2? Okay, so is that fully factored? Yes. Number 3, set each factor equal to 0 and solve. Well, here's one factor equals 0, and here's the other factor equals 0. Wait, why? It doesn't tell us why, it just tells us what to do. I want you to know why. Let's think about this for a second. If I have two numbers, this being the first number, and this being the second number, two numbers multiplied together, that's what I have, isn't it? If I have two numbers that multiply together that equal 0, what has to be true about one of these numbers? It has to be 0, doesn't it? Could they both be 0? Is 0 times 0 equal to 0? But do they have to both be 0? But they could be, right? Okay, so we can't decide which one it is and which one it isn't. We just have to think it's both. Okay, so I take each factor and set it equal to 0. So I have to, what I'm figuring out is what value would I put in for x that would give me a 0 for one of these factors that when I multiplied them together would give me an answer of 0. Does that make sense? Good. Okay, so once I set them equal to 0, I'm adding 3 on each side to get 3. And on this one, a whole separate equation, I'm subtracting 2 from each side to get negative 2. Okay, so are they, did we set each factor equal to 0 and solve? Yes? Okay. So number 4, check solutions by graphing the representative function and comparing zeros of the function. So x squared minus x minus 6. And I graphed it. What am I looking for on the graph? Does the graph cross at at 3, 0 and negative 2, 0? Does it? She says yes. Anyone else? She says yes. He says yes. Okay. So what does that mean about these two answers right here? They are true. They're solutions. And then we're done. Okay. What's another way? This says to check solutions by graphing. What's another way to check these solutions? How do we normally check solutions, right? We normally substitute them in. What's 3 squared? Minus 3? Does 6 equal 6? Okay, what's negative 2 squared? 4 minus a negative 2? Does 6 equal 6? Yeah. Different ways to check, right? Any questions about number A? Okay, so what about number B? What should we do first? Set each equation equal to 0. So how do you want to do this? We have 2 choices, don't we? We can subtract 2x squared from both sides, or we can subtract 5 and add 9x to both sides. So even though it's so much more work, you want to subtract 5 from both sides and add 9x to both sides? Why? To keep the x squared term positive. Excellent. Okay? So if I subtract 5 from both sides and then add 9x to both sides, I end up with 2x squared plus 9x minus 5 equals 0. Okay? Any questions about that? So, did we set each equation equal to 0? Yes. Number 2, factor. First thing we look for is greatest common factor. Is there a greatest common factor? No. Okay, so this is a trinomial with a leading coefficient other than 1. So we find AC and B, right? What is AC in this problem? Negative 10. What's B in this problem? 9. So what 2 numbers multiply to be negative 10 and add to be 9? Negative 1 and positive 10. So earlier, some people tried to go straight to parentheses here, and they wrote x plus 10, x minus 1. Is that what we do here? What do we do? Aren't we splitting our middle term right here? We're rewriting the problem. 2x squared plus 10x minus 1x minus 5. Isn't that what we're doing here? Do you remember that? Okay. Now there's 4 terms in this problem. How do we factor something with 4 terms if we can? We try grouping, okay? Look at just the first 2 terms. What's common? 2x. What's left? X plus 5, right? I'm dividing 2x into each term. What's common in the last 2? Negative 1. What's left when I divide out a negative 1 from each term? X plus 5. So what I end up with is 2x minus 1, x plus 5. Perfect. Is it completely factored? Yes. Set each factor equal to 0 and solve. 2x minus 1 equals 0. X plus 5 equals 0. So add 1. 2x equals 1. Then I need to divide both sides by 2, don't I? Then on the other one, I just subtract 5 from both sides and get x equals negative 5. So now I'm done. That's the right answer. Prove it, right? Check it. How are you going to check it? Okay. You could either graph it or you could substitute it, right? Do which one you're more comfortable with. I went ahead and graphed it for you. Notice it tells me that I have a 0 at 0.50, so that would take care of this one. And I can count over, or remember please, I can actually look at the table and see if at negative 5 it's 0. Oh my goodness. It is. Yes? Some of you look terribly bored, and that's good. That makes me feel happy because you've already figured this out, and you're like, let us go on. Okay, do this one. I'm not going to tell you what to do on this one. I want you to tell me what to do on this one. Let's talk through it, but tell me what to do. Add the 8x like that and subtract 16 like that? Oh, both sides, okay. Okay. Greatest common factor, I hear a lot of people say. What do you mean to do? Divide by 2? What am I left with? X squared plus 2x minus 8. Okay? Now what? Do you have to do A, C, and B on this? Okay. No, because it's a 1. You can. It's still going to be the same thing, right? Since A is 1. What do you want me to write? X minus 2 and x plus 4. Does that work? Okay, now what? Check it? Okay, Kiana's got a good question. I need somebody to answer it. She said, do you have to distribute the 2? What do you think? I hear a lot of good discussion. I just don't hear any conclusions. Is 2 a factor of this equation? Okay, so don't I have to continue following the rules? What's the next rule? It says set each factor equal to 0, right? So what would happen if I said 2 equals 0? 2 doesn't equal 0, does it? So what do? I ignore it. 2 doesn't equal 0, so it doesn't come into play into my solutions. Okay? But if I set the other 2 equal to 0, those do come into play in my solutions, don't they? You guys are ridiculous. Oh, that was just me. I was humming. Yeah, sure it was. Is this right? Now we check it, right? We can't check it till we have any answers, right? Okay. Is it right? Yes? Good. Questions? What do you do for homework? Last 4. Okay, 5, 6, 7, and 8. You have a lot of time. Okay, you have some time left in class. Do you have any questions? If you do, please ask before you leave. Don't go home with questions. Okay? Peace.